Hey, this is John here, and we are going to do binary search in Python. So let's get started. We want some random numbers, so import random, and let's just do some integers. So if we do random.randint 0 100, that should give us some random number between 0 and 100. There we go, 66. Okay, but we want more than that. We want a list of that. So let's do that for x in range, say 0 to 20. Call that A. And print A. There we go. There's our list of 20, and let's just make that a variable, size 20. There we go. 20 random numbers. Okay. For binary search, we need the data sorted. So we can just do a dot sort. And print A again. And now we have a sorted list of random numbers. And before we sort it, we'll just make our value to find. Say search. Now let's just do just pick one in the middle of our search now is equal to size divided by 2. So just somewhere halfway through the list, we're just going to pick one. So print search val and a search. Okay, for this instance, we would be looking to see if 95 is in the list. Okay, so we've got that. Let's make our recursive function for binary search. So we'll define binary search. Let's just call it search. It's going to take an array. It's going to take a value to find. It's going to take a lower limit and an upper limit. Okay, this is a recursive function. It's going to call itself. So I always start with the terminating conditions when I do recursive stuff. So we're going to say if upper minus lower is less than 2, then we can return if the array at the lower limit is equal to the value to find, or the array at the upper limit, Python or, okay, if the array at the upper limit is equal to find. So if that's the case, we found it, we'll return it. Okay, otherwise we need to keep searching. So we need to calculate the midpoint between our lower and upper bounds. So we'll say mid. That'll be equal to upper minus lower divided by 2. I need to make sure that's an integer. So I'll just cast that to an integer. And then that tells us the distance, but we need to offset it from the lower portion. Like say upper's 4 and lower's 2, then upper minus lower is 2 divided by 2 is 1. But we don't want 1, we want 3 because 3 is in between 2 and 4. So this gives us the midpoint there. Okay. And we can say if the array at the midpoint is, let's say, greater than the thing we're looking for, then we can do a search on the bottom half, because the thing defined must be in the bottom half of this. So we'll search the array to find again. We're going to pass in the same lower bound and then the new upper bound of the midpoint. And I'll return that. Otherwise, we'll return a search of the upper half. So say of the array to find from the midpoint to the upper. Okay. So let's test that out. Okay, let's do search. We're going to search A for our search val. And the lower bound will be 0 and the upper bound can be our size. Okay, index out of range. Oh, I added upper when I should have added lower. There we go. And we want to print our result. Okay, it found it true. What if we had 200 elements? And it still found it true. What if we had an odd number of elements? 1989. Still found it. And now, that's good. If we, instead of picking one from the list, we'll say something outside of these bounds, like -1. That should return false. That's false. Or 101 is outside of the bounds. And we got index out of range. Probably should have make this size -1. Okay. So that gave us false. Try -1 again. That's false. Search let's just pick the third element. True. I can make that bigger. Still true. All right, let me see. Even though we're searching through nearly 200,000, let's say 2 million elements. Float can't be an integer. Fine. 2 million elements. Okay, still got through there in a reasonable amount of time. So if we tried to do just a linear search, that would take quite a bit longer. That would be order n time, because we're going to look through n elements, so 2 million elements. But here we're doing log n because we're dividing and conquering. Alright, that is binary search in Python. Thanks for watching.